Hello, good morning. I am Dr. K. Pungodi, Professor, Department of Civil Engineering and Director, CCMM, SR University, Varangal. Today's topic is super elevation on highways and railways. This topic contains a definition, importance, forces acting on super elevation, derivation, difference in super elevation on highways and railways, effect on new corridors, specifications, conclusion. Definition. Superelevation is one of the most important geometric design elements used in highways and railways to ensure safety, comfort, and stability of vehicles while negotiating horizontal curves. In India, the design standards for highways are given by Indian Road Congress, that is IRC, while railway standards are followed by Indian Railways. When a vehicle moves along a curved path, it experiences centrifugal force acting outwards from the center of the curve. If the road or track is flat, this force can cause skidding of vehicle, overturning, passenger discomfort, increased wear on tires or rails. To counteract this force, the outer edge of the road or railway track is raised above the inner edge. This raising of outer edge with respect to inner edge is called as superelevation or cant. In railways, see that the outer rail is raised, and because of the raise in outer ends, a slope, that is transverse slope, is formed at the horizontal curve on railways related to the inner ends. It counteracts centrifugal force, reducing the risk of vehicles sliding or overturning and improving the safety and comfort for vehicles traveling at design speed. On highways also the same concept. And what is the importance of the superelevation? It counteracts the centrifugal force. When train negotiate curves at speed, the centrifugal force acts outwards, threatening to push the train off the track. So the superelevation uses the gravity to counteract this force and enhances stability and safety. By reducing the lateral acceleration felt by the train, it prevents the risk of derailment or overturning, especially for the fast moving trains. It improves passenger comfort. It minimizes the lateral outward push experienced by the passengers and jerk and provide a smoother, more comfortable ride. It reduces the maintenance cost. Properly designed superelevation ensures an equal distribution of wheel load on both rails, significantly reduces the wear and tear on the rails and wheel flanges, so that wear and tear at the curves will be uniform for both the inner and outer rails, and it allows the higher speeds. It permits trains to travel at high speed throughout the entire curve. Balanced movement. It balances the centrifugal force with the gravity at a specific desired equilibrium speed. What are the forces acting on superelevation means? These are the key forces which are involved in the superelevation. These forces are continuously repeating in our entire journey. See that the first foremost force is the centrifugal force, which is acting outwards. It is mentioned by P. P is the centrifugal force which is acting outwards. And weight of the vehicle. The entire weight of the vehicle, because of the gravity, it will act downwards and it will be mentioned by the W. Centrifugal force by P and the weight of the vehicle by W. Then normal reaction forces from the pavement, that forces are named as Ra and Rb. They are acting upwards. Then lateral friction forces of the track. they are acting inwards, that is FA and FB. See the picture here. The centrifugal force, this is the centrifugal force from the center of gravity, it acts outwards. Then weight of the vehicle, which is acting downwards. Reactive forces act at here. They are RA and RB. And the frictional forces which are acting towards inwards. So these are the forces involved in the superelevation, and we have to consider the forces while deciding the superelevation. And objectives, already we saw that it neutralizes the effect of the centrifugal force. It equally distributes the wheel load, providing smooth track, improving passenger comfort. It reduces wear and tear of the rails and rolling stock. Here, this picture clearly explains about that what are the forces acting. The first and foremost force, see here, first, here the outside rail is slightly increased so that the entire vehicle will turn like this, turn inside. So when the vehicle is turning inside, at the time the centrifugal force will act outside. Kindly note that the first foremost force which is considered while designing the superelevation is the centrifugal force. This is the center of gravity point. From the center of gravity point, the P, that is centrifugal force, which is acting outwards. Next one is weight of the vehicle. Weight of the vehicle, it is in terms of tons, and it is also dynamic load which is acting downwards due to the gravity. From the center of gravity, the weight of the vehicle is acting downwards. Now, this vehicle is turning inside while crosses the curve, so that this centrifugal force is divided. And see here, here it is P cos theta and here W sin theta, like that it is compensated. And here the it is acting slightly inwards, so that here the angle theta is made, and the resolving forces of W is W cos theta and P sin theta. These are the forces formed from the P and W. So the P and W now compensated by the P cos theta and P sin theta, then W sin theta and W cos theta. By equilibrium conditions, if we want to maintain the equilibrium conditions and want to avoid the accident, then the P centrifugal force, we know that the formula for the P is WV squared by GR. P is the centrifugal force, V is the velocity of the vehicle, W is the weight of the vehicle, G is the acceleration due to gravity, and R is the radius of the curve. This is called as the Formula 1. From the figure, here this is the inner edge and this is the outer edge. This distance is the rise in the normal level, and this rise in level is called as the superelevation and mentioned as small g. In transportation engineering, wherever we are mentioning small g, that indicates the superelevation. Now, see here from the figure, this g, that is tan theta. What is the formula for tan theta? That is opposite side by adjacent side. Therefore, this tan theta is here. This is the opposite side and this is the adjacent side. That adjacent side is nothing but cage or width of the road. Cage means at the railway track and width means that is the width at the highways. The below forces are acting on the vehicle weight of the vehicle W, centrifugal force P, frictional forces, and the reactive force also. Here, we want to maintain that equilibrium condition and avoid the accident and the equal wear and tear on the both rails. Then this P cos theta, which is acting outwards. This P cos theta acting outwards should be compensated by the internal acting forces. What are the internal acting forces? Here P cos theta is the external force and this P cos theta is the P cos theta which is acting outwards is compensated by the internal acting forces. The internal acting forces are three forces. One is W sin theta and after that the frictional forces F1 and F2. So the external force is compensated by the internal forces acting. So P cos theta is equal to W sin theta plus F1 plus F2. This W sin theta is the component of the centrifugal force which is acting inward and F1 and F2 are the frictional forces. These forces are also acting inwards. So that the P cos theta, the outward force, is compensated by the internal forces. Now, in the next step, we can see that how that frictional forces are able to compensate it. These frictional forces F1 and F2 are compensated by the upward reactive forces. What are the upward reacting forces? They are R1 and R2. That R1 and R2, if we are multiplying by the frictional force F, that is small f, then this first step is converted into W sin theta plus f of R1 plus f of R2. Here see that this F frictional force is the common factor. So we can take it at outside. So the formula once again turns into W sin theta plus F of R1 plus R2. Now see that this R1 and R2. What are this R1 and R2? This R1 and R2 are the upward forces. These upward forces should be compensated by the opposite forces. And here what are the opposite forces means they are the W cos theta and P sin theta. So this R1 and R2 can be replaced by the P sin theta and W cos theta. So the next step is converted into W sin theta plus F of P sin theta plus W cos theta. This R1 and R2 are replaced by the P sin theta and W cos theta. Now we can take that the P components to the left side and W components at the right side. What are the P components? P cos theta and Fp sin theta. So here Fp sin theta is in plus. While coming to left, then it can be converted into minus. So P cos theta minus Fp sin theta, that is equal to now W sin theta plus Fw cos theta. See that here the left side components are P and the right side components are W. So we can take that here left side P at outside and here right side W as the common factor. So here P by W, P by W is that is the common factor at left side and we can divide them both sides by W cos theta. So P by W of cos theta by cos theta minus f sin theta by cos theta, that is equal to sin theta by cos theta plus f of cos theta by cos theta. So here in this stage, P by W minus Fp of tan theta, that is equal to tan theta plus F. So because of dividing W cos theta on both sides, we are able to get that P by W of 1 minus F tan theta, that is equal to tan theta plus F. So here this 1 minus F tan theta, it can be shifted to the right side, so that we are able to get that P by W is equal to tan theta plus F divided by 1 minus F tan theta, that is equal to tan theta plus F. And here P by W is equal to E plus F. How E plus F means this tan theta plus F divided by 1 minus F tan theta. By calculations, we are able to get 0.999, so that it is considered as 1. And finally, we are able to get that E plus F. So then, here P by W is equal to E plus F, and in the equation 1, already we arrived that P by W is equal to V squared by ZR. So now this P by W and that P by W, that is um, V squared by ZR, can be compensated, and because of that E plus F, that is equal to B squared by ZR. And this V is equal to V squared by ZR. In this, V is in meter per second. So this meter per second should be converted into kilometer per hour. How this meter per second should be converted into kilometer per hour means, here to convert into kilometer, we have to multiply with 1000, and seconds to hour 60 by 60, that is 1000 by 3600, and we are able to get the factor 0.27. So now this small b, which is in meter per second, is converted into capital B, that is the multiplying factor is 0.27. So with this, once again this formula can be converted into 0.27 square B square. Now this B is in kilometer per hour divided by, and we can apply the formula for Z, that is 9.81 of R. And finally we are able to get that 0.007 B squared by R. And this 0.007 can be rewritten as 1 divided by 127. So now this entire formula is turned into B squared divided by 127 R, and where E is the rate of superelevation in percentage, capital B, that is the velocity of the vehicle or speed of the vehicle, which is in kilometer per hour. F is the lateral frictional force, that is 0.15. G is the acceleration due to gravity, 9.81 meter per second square. R is the radius of the circular curve in meters, and if the velocity is in kilometer per hour, then E plus F is converted into capital V squared divided by 127 R. Now we can, since we are assuming that the design speed is 100 kilometer per hour, but in practical we are not able to maintain that 100 kilometer per hour throughout the journey, so that we are considering only 75 percentage of the design speed. If we are considering only 75 percentage of the design speed, then how this formula can be changed means, that is the basic formula for calculating the superelevation is E is equal to V squared divided by 127 R if we neglect the frictional force, since the frictional force is very small. So F is equal to 0, and instead of 100 kilometer per hour we are considering only 75 percentage, then that is equal to 0.75 V. So E plus F is equal to V square divided by 127 R, once again converted into V square divided by 225 R. Kindly consider that now the design speed is, the practical design speed is only 75 percentage, that is 75 kilometer per hour instead of 100 kilometer per hour. See here, for railway track, the super elevation is calculated as follows, since it depends upon the gauge. Here at railways we have different gauges, that is broad gauge, meter gauge and narrow gauge, and based upon the gauge we have to introduce the gauge also, that is G. So that the super elevation E is equal to GV square divided by 127 R. And as per the guidelines, the maximum value of the super elevation generally adopted around many railways around the world is 1/10 or 1/12 of the gauge. And if we maximum gauge at railways in India is broad gauge, and if we want to introduce the broad gauge, then we have to give the value of 1.676 for the G. So it will be once again 1.676 of V square divided by 127 R. And what are the limitations as per Indian Railways means here, this is the cage. The cage is nothing but that is the inner to inner distance of the two rails. And in this picture, the outer rail is raised with respect to the inner rail. Once again, the cage is maintained the same. And the super elevation limitations for broad gauge as per Indian Railway standard is 16.61 centimeter, meter gauge 10.16 centimeter, and for narrow gauge it is 7.62 centimeter. Broad gauge, mostly 95 percentage of the track in India is broad gauge only. Meter gauge is there at a few hill stations, and narrow gauges are constructed which are connecting the main track with the industrial areas. So here, this meter gauge and narrow gauge contribution in India is only 5 percentage, and the remaining gauge is broad gauge. So we have to adopt that the super elevation at the curve is 16.61 centimeter. That is the maximum value. And here, important IRC limits, that is for highways, the maximum super elevation in India for snowbound areas it should be 10 percentage, and plain it should be 7 percentage. And see here how the super elevation can be introduced on the curves. See here, this is the plane. In this picture, this is the, that is tangent runout, that is plane area. And here this runoff area here, this, this is the circular curve. From the circular curve, we are introducing the super elevation. And here this is the crown area. And here once again we are turned to the normal track. And here simply we are not able to introduce the super elevation. Here camper also to be adjusted. Since camper is the elevated portion at the center to run off the drain water. But this camper is not able to given at the circular curve of both railways and highways. And here, since already the outer edge is raised, so that at center the crown should not be there, that is the camper should not be there, so that the entire rainwater should be collected at the inner side of the curve, and slowly once again reduced, further reduced, and from the uh, circular curve to the transition curve, then transition curve to the plane. Like that, we have to introduce the curve. So the camper also to be adjusted at the curve to compensate the super elevation. Since here the center portion is elevated, but at the curve the outer portion is elevated. And how the superelevation development is transmitted at the transition curve, and the superelevation cannot be introduced suddenly, so it should be applied or developed gradually along the entire length of the transition curve, and the stages which are include are removal of the normal camber, gradual rotation of the pavement, achieving full superelevation, and the transition curve provides smooth change from straight road to the curved road by applying the above stages. And passenger comfort, without proper super elevation, passengers experience strong lateral forces, so that it reduces the sideways jerk, provides smoother ride, and it is especially important for the high speed trains. And a reduction in real and wheel bear. When tracks are properly super elevated, load is distributed evenly on both rails, wheel flanges contact reduces, and it leads to less rail wear, reduced maintenance costs, and increased track life. And how it is balanced in new railway line construction. By selecting the proper curve, engineers first select an appropriate curve radius, and the larger radius are more comfort than the smaller radius. So the larger radius are lead to the smaller centrifugal forces and less super elevation only required. So for high speed railways, we are using very large curve radii. Now for normal track which are constructed up to now, we are using the maximum radius of 400 to 600 meter. But for the high speed rails, that is HSR, we are introducing more than 2000 meter. From 2000 meter to 6000 and 8000 meters, the radius will be increased, so the development of the centrifugal force will be very very less, and no need about the entire risk of the super elevation, and simply we are able to maintain the maximum speed. Nowadays the speed of the rails are planned to increase up to 350 km per hour. So from the 60-70 km per hour, we want to introduce that 350 km per hour. Then for the engineers, the super elevation is the important criteria. How simply it can be compensated means with the maximum curve radius. And this picture shows that about the track cage, and this center of the track, and this is the inner track, and this is the outer track, and how this outer track, how it can be raised from the ballast. Simply rail should not be able to raise it. So ballast cushion should be raised so that the sleeper will be raised and the rail automatically will raise. So proper track maintenance is very very important. Even well-designed super elevation must be maintained for the track alignment, rail leveling, ballast maintenance. Regular inspection ensures the cant remains balanced. So this topic is very very important for the transportation engineering, highway engineering, railway engineering, and for students GATE exam, SSC, junior engineers, and the civil engineering exams. And some of the MCQs. The first question, what is the definition of the super elevation? The options are difference in height between the outer and inner rail, height difference from outer rail to center of the track, height difference from inner rail to center of the track, slope at which rail is laid. And we already know that That is the difference between the height between the inner rail and outer rail. So the option will be A. The second question, what is the formula? Which of the following is the correct formula for equilibrium superelevation in millimeters? Further, the formula is GB square divided by 127 R. And the superelevation that is to be provided on the curve depends only on the maximum speed of the fastest train. Is it true or false? Means it is completely false statement, since the superelevation to be provided also depends on the average speed of the goods traffic moving on the section. This is done to make sure that slow trains move safely without any chances of derailment due to excess current or super elevation. The next question, as per the prescribed value, what should be the maximum value of the super elevation excess on the broad gauge? And the answer is the maximum value should be 75 mm. And for meter gauge, it is 65 mm. And the super elevation needed for the vehicle traveling at a speed of 60 km per hour on a curve of radius 128 meter on the surface with a coefficient of friction of 0.15. Then the value will be, when we apply the formula Gv square divided by 127 R with the change, then we are able to get the 71 mm as the answer. Yes, that's all about the super elevation. Thank you. Thank you so much.